Welcome to the Quantum Apartment Building. And just as the title says, it's full of lazy tenants and stinky roommates. So if you would like to pause for just a minute, you will need to obtain about 35 to 40 pieces to do this activity. They could be beans, you could use pieces of rice, you could cut up little pieces of colored paper, anything that could represent your tenants. So you can pause this and run and get something to play the activity with. Okay, now that you are set with your beans or whatever it is you're going to use, get out your the sheet that you got in class that has the Quantum Apartment Building pictures on it. And we are going to put tenants in this building. And don't forget, there are no elevators. They have to walk up the stairs. And above all, these tenants are lazy. And in addition to being lazy, they're all stinky. So they don't really want a room together. So our first tenant comes along and he is going to find a room. And where do you think he might choose? If you guessed apartment 1S, I guess he's not only lazy and stinky, he's messy. There we go. He chooses apartment 1S because he's lazy and he doesn't want to go any higher or expend any more energy than he absolutely has to. And his buddy comes along and wants to live there too. He really doesn't like living in the same room with his stinky roommate, but he, even more than that, doesn't want to climb the stairs and waste his energy doing that. So he will choose that room right there in that bed. That's where he gets. So if you are wondering why in the world are we doing this really weird activity, well, think about a couple of the atoms on the periodic table. Think about hydrogen. How many electrons does it have? 1. Our first tenant was a lot like hydrogen with 1 electron. The second tenant was a lot like helium with 2 electrons. And so you can keep that in mind as we continue on this. We're not just being extremely weird for no reason. We are going to relate this to some chemistry. So let's say we have a third tenant and he wants to live somewhere. He is going to choose the 2S apartment. It's a lot cheaper than the 2P apartment. 2P has 3 rooms in it and it's really expensive. So he's going to choose the 2S apartment. And he certainly wouldn't want to go up any higher in energy and live on the 3rd floor. So when we have our 4th tenant, he's going to live here. Because once again, he would rather live next to another stinky roommate than actually pay for that more expensive apartment with the 3 bedrooms. Now, let's say we have another tenant who comes along, and he's going to, of course, has to live in the 2P. He doesn't want to climb the stairs up to 3S. But then he has 2 buddies that would like to live there too. And they certainly aren't going to double up. They're going to first choose that room, and the next roommate will choose that room. And just keep in mind that's exactly what electrons do as well. They fill up the orbitals in that way before they go back and double up. So now we have another tenant come along, and he certainly is going to choose to live with a stinky roommate rather than go to the 3S apartment. And the next tenant chooses here, and the next tenant chooses here. So now that we have the 2nd floor occupied, another tenant comes along and would like to live somewhere, and the lowest energy he can expend would be climbing up to the 3rd floor, so he stays there. And once again, in a similar fashion, the next tenant who comes along will have to live here because he doesn't want to rent the 3P expensive apartment. And when, let's say, 6 more people are in line and they'd like to rent, and they will definitely rent in this order. They will fill up separate rooms first and then go back and double up. Now, the interesting thing we have next, we have another tenant. But this tenant is going to actually go up to 4S before he rents apartment 3D. 3D is so expensive with 5 rooms in it that he is going to choose the 4S apartment, and his buddy who comes in after him will also choose the 4S. And thereafter, tenants will decide to choose apartment 3D, and they will fill apartment 3D up in a very similar way as the P apartments. They will fill them up like this, filling up each room separately before they go back and double up. Now, interestingly enough, this is exactly what electrons do. Something to point out with electrons. These are actually orbitals that we've been talking about rather than apartments. And when we talk about them, this strange phenomenon at the 4S orbital where we jump up to the 4S before filling the 3D, it's because the 4S is actually lower in energy than the 3D. So this little chart that you also have, and you'll be able to look at it on the test, so you don't have to memorize it, but it shows very conveniently the energy increase in orbitals. So we have 1s first, then we come up, and 2s is the next energy in energy. Then the next highest energy is 2p, and then 3s, then 3p, and then 4s, and then 3d is higher in energy than 4s, and then 4p and 5s and so forth and so on. So it's a nice way to remember that because it doesn't exactly follow just the principal quantum number. Okay, now you have a chance to practice. Instead of doing stinky roommates, we're going to look at atoms and use electrons and see how they fill their shells. So let's start with lithium right here. If you'd like to pause, try it on your own, and then you can watch and see if you get it right. So for each one you can pause. You might grab a periodic table too so that you can determine how many electrons each of them have. Lithium has 3 electrons. So lithium will be filling orbitals with its electrons in this manner. That's pretty simple. Boron, let's look at boron. It has 5 electrons. So we'll need to put 2 more electrons. One will go here, and the next one will go in the 2p orbital. And that's boron. So let's look at silicon. Silicon has 14 electrons. So we already have 5, 6, 7. Remember, 1 electron goes in each of the orbitals before it goes back and doubles up. 8, 9, 10, 11, 12, and then 13, 14. And that is what silicon's electron placement would look like. Also, keep in mind, we've mentioned the Pauli exclusion principle before, but for any one orbital, only 2 electrons can fit in that orbital, and they must have opposite spin. So that's not being represented right here, but one would be spin up and one would be spin down. Let's do argon. Argon has 18 electrons. So we need to put 1 more in that third 3p orbital and then go back and double up. Let's see, and that's 18. So that is the electron placement for argon. Now calcium. Calcium has 20 electrons, so it only has 2 more than argon. And those electrons will not go in the 3d orbital, they will go in the 4s. Remember, if you look at your energy diagram, 3d is higher in energy than 4s. So the electrons will fill 4s first before they go up to the 3d orbital. Now let's look at bromine. Bromine has 35 electrons. So we're going to go to the 3d orbital for bromine. And remember, the electrons will occupy separate orbitals before they go back and double up in that 3D apartment. We need 5 more, so the next energy level up from there is the 4p. And that is how bromine's electron placement would look. So hopefully you have fun a little bit here, and try to come to class ready to do some electron configurations. Thanks.